Yeah, good morning, students. So it's my pleasure to introduce this CDT on DQ. So I would like to share my screen. Hope my screen is visible to you. Fine. So this is the today's topic for discussion. So week 7 lecture 2 topic is DQ. So summary of the previous CDT, if you see that in the previous CDT we had a discussion on the circular queue and its operations. So in circular queue we have performed this insertion and deletions. While we are performing that insertions and deletions, we checked whether the circular queue is full or not. So please see that in that circular queue the index variables are rotated in a circular manner. Okay, so in the linear queue we have seen that there is some problem. To overcome that particular problem, we have made use of the circular queue implementation. Fine. So today's lecture objectives is that what are the operations we can define on a DQ, and how do we implement those operations. Outcome of this today's session is that upon completion of this session, the students should be able to develop the code for implementation of the DQ's data structure using arrays. So what is a DQ? So DQ, its full form is double-ended queue. So it is a type of queue in which insertions and deletions of elements can be performed at either end of the queue, that is from front or rear end. Thus it does not follow a FIFO rule what we have followed in circular queue as well as in linear queue. So DQ is a double-ended queue, so where from both ends you can perform the insertion as well as the removal, you can perform that. So what are the different types of DQs? So there are two different types of DQs are there. One is input restricted DQ. Okay, so the restriction is on input operation. So that means you can do the insertion at one end only. Okay, so the insertion can be done at one end only. That is at rear end you can insert it, but the deletion can be done from both the ends, from front end as well as the rear end. Fine. So the insertion can be done from rear end only. So that is the input restricted DQ. So the restriction is on insert operation. Fine. So deletion can be done from both end, but insertion can be done at only one end, that is at rear end only. Then coming to the second type of DQ, which is called it as output restricted DQ. Okay. In this DQ, output operation is restricted, that is the delete operation is restricted. So that means you can delete from front end only. So you can delete from front end only, but insertions can be done from both the ends. Okay, insertions can be done at both the ends. So deletion can be done from only front end. Got the point? So this is what we are calling it as output restricted DQ. So now what are the operations we can define on this DQ? Simple. Again, insertion at front, insertion at rear, deletion from front, deletion at rear. So like that we can perform these operations and display the queue contents. So we can define all those operations. Fine. So now insert at the front end. So if the queue is empty, both rear and front are initialized with 0. Now both will point to the first element. Otherwise, check the position of the front. If the front is less than 1, that is then initialize it by front is equal to n minus 1, that is the last index of the array. Fine. So like this here, what we are doing here is that in this insertion operation, the element is inserted from the front end of the queue. So before implementing this operation, we have to check whether the queue is full or not. If the queue is not full, then the element can be inserted from the front end by using the below conditions. Fine. So when we are, for example, if you see in this particular diagram, front is here and rear is here. So since there are some empty locations, we can insert the element into the front. So when we want to insert an element at the front, what we have to do here is that, So we are reinitializing it to front equal to n minus 1 as the last index, and we are inserting a new element here. So insert at rear. So in the insert at rear, it is normal here. So we are incrementing this rear value and we are inserting that element. Fine. So when we are inserting at the rear, so we have to check this condition here. In this operation, the element is inserted from the rear end of the queue. So before implementing the operation, we first have to check whether the queue is full or not. If the queue is not full, then the insertion can be done from the rear end by following these following conditions. So if the queue is empty, both rear and front are initialized with 0. Now both will point to the first element. Otherwise, increment the rear by 1. If the rear is at last index or size minus 1, then instead of incrementing it by 1, we have to make it is 0. So deletion at the front end. So if we want to delete that, if the DQ has only one element, set rear is equal to minus 1 and front is equal to minus 1. Else front is at end. That means front is equal to size minus 1. Set front is equal to 0. Else increment the front by 1. So in this operation, the element is deleted from the front end of the queue. So before implementing this operation, we first check whether the queue is empty or not. Fine. So these are the conditions. So this is deletion at the rear end. So if rear is equal to 0, rear is at front, then set rear is equal to n minus 1, else decrement the rear by 1. So in this operation, so the element to be deleted from the rear end of the queue. So before implementing this operation, we need to check whether the queue is empty or not. So if the queue is empty, so we have to see that front is equal to minus 1, then the underflow condition cannot be can be performed here. Underflow, queue is underflow, deletion cannot be performed. If the DQ has only one element, set rear is equal to minus 1, front is equal to minus 1 after deletion. So what are the applications of the DQs? DQs can be used as both stack and queue. So that supports both the operations, stack and queue operations. DQ can be used as a palindrome checker, that if we read the string from both ends, the string would be is checked easily with whether that is a palindrome or not. Fine. So this is a program implementation. You can refer this. Okay. So we are calling this insert front 20, insert front 10, rear, insert rear, insert rear, insert rear, like that. Display, get front, get rear, delete, like that. We are implementing all these functions. So please go through this code. So insert at front. So when you are inserting at the front, the overflow condition is very important. So if f is equal to 0 and r is equal to size minus 1, in this particular case, the queue is full. Or f is equal to r plus 1 case also, the queue is said to be full. So else if f is equal to minus 1, r is equal to minus 1, we have to kept f and r at 0th location. If f is equal to 0, then f is equal to size minus 1 we are keeping, and we are inserting at dq of f location, we are inserting x. Fine. So else again we are checking f is equal to f minus 1, dq of f is equal to x. Fine. This is what the code here is that, and this is the insert here. So similarly, you can see this particular code. So only thing here is that please try to understand what are the conditions we are writing for overflow and what are the conditions we are writing for underflow. That is the only thing. Everything will be as in the similar grounds what we have written for circular queue as well as DQ operations. Okay, so it is very easy for us to understand this particular code once you understand the implementation of linear queue as well as the implementation of circular queue. So it is very easy. The conditions will be little bit similar to the circular queue conditions, whether the queue is full or empty. Fine. So this is the code as it goes like this. All these four operations, delete front, delete rear, we are implementing here. Fine. So now coming to this reflections part. So compare input restricted DQ with the output restricted DQ. Fine. So if you are not able to answer what is the difference between input and output restricted DQs, so please watch the video from the beginning. So the lecture outcomes revisited here. After completion of the session, students will be able to develop the code for implementation of the DQ operations. So the summary of the session is that DQ, which stands for doubly ended queue, is a type of queue in which insertions and deletions can be done either from the front as well as from the rear. So it does not follow the FIFO structure. So we have seen that there are two important types of DQs: input restricted DQ, where The restriction is on input insertion operation. So insertion can be done at only rear end, but deletions can be done from both the ends. Whereas in output restricted DQ, deletion restriction operation is on deletion operation. So deletion can be done from only front end, but insertions can be done at both ends. So this is a lecture level practice problem. Write a program to create the queue using arrays which permits insertions at both the ends. These are the further readings. Fine. So thank you one and all.